Well, good morning, everybody. I just wanted to share this cup. I think this is super cute, but also there's actual math on there, right? Isn't that pretty cool? It's really cool. Some of you should recognize some of that from geometry, but I'm a math teacher. Of course I have problems. Pretty cute. All right, let's go down to what we're doing. This is the TGA video. What does that mean? If you're watching this just like on YouTube or with the video link, you're watching this video to help you complete the assignment that you're going to upload. Okay, so to look a little bit different, let me view as a student and start over. You'll download a PDF, you'll download the Word document, you'll either write on it on the computer or you can write it on paper. You can print it out. You don't have to print it out. So lots of ways to complete this. I'm very open. Again, all I care about is that you guys are trying, you're thinking, and you're allowed to be like, I don't know, like this is what comes to mind. This is what I want to do, but I'm not sure if that's what I'm supposed to do or if that's the right answer, but this is what I'm doing right now. That's okay. Again, watch these videos for the answers. Don't go looking on the internet because math is actually quite hard to find the answers. It really is. So I don't want you to think that it's going to work in other classes or especially not in college. You kind of need to, if you're going to search the internet, you kind of need to be looking for the understanding piece, like what is happening. And I'll give you those resources or I'll be that resource. So just reach out. I'm nice, I'm friendly, and I care about students. So I won't make you, I'll do my best not to make you feel bad. I want it to be fun. I want you to feel a part of this math class. They're making you take Algebra 2. I'm not making you take Algebra 2. They are making you take Algebra 2. And I'm here to help you succeed, pass, earn that great credit. Okay, so this is what it looks like as, if you're watching the play, pause it. We're going to get to it. You know, you can always skip forward because I have the settings set like that. This is the teacher graded assignments. They are in multiple courses. This is our math course one. So here's where the material is coming from, right? I'm going to click the PDF so you can see it. Aha, so this is it. You can print this or you can download it and write on it digitally, or you can just write this out on paper. You don't have to. You can just write, okay, question 1, fundamental theorem of algebra, 2x squared plus 4x, blah, 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 right? What are the roots? And then you can just solve your work on paper and upload that. Okay. How do I go back? I don't know what just happened there. Oh, that's the unit test. That's fine. Here's the part 2. Okay, when you're done, this is where you upload it, right? And then you can type something in here if you like. You can even record something. Sure. Last year I had students audibly record their answers and describe it to me. One student would just hold it up to the camera and pull it away. Hold up to the camera and pull it away. You got to be careful just so I can see the work. And then we figured that out. We made it work. Okay, and then you'd hit down at the bottom, you'd scroll down to hit that blue submission button, which I guess I don't have. Upload something. Oh, there it is. See? Okay, cool. Right there. Then you can submit it. Okay, you can hit submit. We're not going to do that just yet. We're going to go ahead and download. That's fine. I want to download it. Cool. Mine comes up here, so then I go ahead and open it. This is funny. I just have to show you this. This is really funny to me. Word can't do this because a dialog box is open. Please close the dialog box to continue. I didn't know. It's funny. It's just funny to me because I just clicked on it to download and then Word gave me that warning. Like, we can't actually open it because this dialog box is open. So close this dialog box so we can continue. Enable editing. Some students got stuck here because this little button at the top just didn't pop out, but you need to click that often. If you don't have Microsoft Word, every student with Arizona Virtual Academy or any K-12 powered school has access to Microsoft Word, PowerPoint, Excel, Outlook, quite a lot of the Microsoft Office products. Not all of them, but a lot of them. Here we go. Time to get to work. Enough rambling. Use the fundamental theorem of algebra to determine the number of roots for 2x squared plus 4x plus 7. What are the roots of 2x squared plus 4x plus 7? Show your work. Okay, here we go. Part A says that theorem, if a polynomial of degree n with n greater than 0, strictly greater than 0, can't be equal to 0, then that polynomial has n complex roots, where m is where the roots are counted m times, where m represents the multiplicity, meaning the number of times it's repeated. Okay, so that's kind of the word version, but you can always look that up. That's a perfect thing. What is the fundamental theorem of algebra? And it'll kind of help you and might even have some examples. So I have the draw function. If you guys don't have the draw function, there's lots of creative ways to write on here. One is the snipping tool or snip and sketch. You could just take a snip, use that to draw, and then paste it in here. Or you can just use any type of writing. If you want to do it virtually or digitally, you can use any type of writing application that you have, and then just remember to label them. Number 1, list this polynomial, and then show your work. So here we go. A, according to the fundamental theorem of algebra, 2, complex roots. Remember, complex roots includes real roots and imaginary roots. B, what are the roots of 2x squared plus 4x plus 7? Because this is also a learning, that's where we're going to go. I guess Desmos. 2x squared, I already forgot, plus 4x plus 7. Let me go check. Yep, cool. 2x squared plus 4x plus 7. There it is. We talked about this in class. For those of you who weren't in class, notice this is a graph of a parabola. That should be kind of familiar. You should kind of, I remember that. I heard that name, parabola. It's a quadratic equation. It's a graph of a quadratic equation. We've got ourselves a y-intercept at 7. Look what the constant term is. We have a minimum of 5. The vertex, I don't know if that sounds familiar, is at -1, 5. It's opening upward. So this parabola will never intercept the x-axis, which means there will never be any real roots, any real numbers that will make this equation equal to 0. So this will always be positive. When that happens, we have complex numbers to think about. It is in the complex plane. There are solutions to this. They're just going to include the letter I. So how could we figure that out? Well, at this point, I would just go to the quadratic formula. That's what we're going to do. Remember, I've talked about this before. My differential equations college professor, Dr. Pranari, admire her teaching style, still trying to work up to her level of rigor and preparedness. She always challenged us that she would get to the solution first by using the quadratic formula. Sometimes we beat her because when they're really easy to factor, after you've done it for so long, they just kind of, some of you have noticed this, it just kind of popped in your head. Like some of you even say, well, I just guessed correctly. Well, your brain was solving it with the patterns that you've used, and that guess is because of you recognized that and you saw the relationship. So that does happen as you repeatedly do something, anything in your life. It becomes what we call muscle memory, and your brain is a muscle. So there it is. B. What is the B, A, and C? Remember, they're the coefficients. A is the coefficient, the number part in front of the x squared, the quadratic term. B is the coefficient, the number in front of the linear term, the just x term. And C is the constant term, the term without a variable, without a letter. Now we just need to plug it in. Opposite of B, well, B is 4, so it's -4. Plus or minus the square root of 4 squared minus 4 times 2 times 7, A and C, all over 2 times 2. At this point, we just need to keep simplifying. So negative 4, I'm going to split it already. It's 2 times 2 is 4, right? So that's fine. Plus or minus. So I'm just splitting the fraction at this point, plus or minus, meaning we're going to plus and subtract to help with simplification and maybe talk about what's going on up here. Okay, the numerator, though, is 16 minus 4 times 2 is 8 times 7 is minus 56. Okay, well, that equals, this simplifies to negative 1 plus and minus the square root of negative 40 over 4. You can't directly divide into there, so don't do that yet. We've got to simplify the radical before we can divide anything. This isn't rationalizing the denominator where you have the radical on the bottom and you need to bring it up. It's fine. We're fine with having a radical on the top on the numerator. Okay, but we do need to simplify this. So I'm going to pause. I'm going to circle this, and we're going to go over here and simplify it. So here we go. This negative 40, actually just this part, the square root of negative 40. So the square root of negative 40 is equal to I times the square root of regular 40. Because we just take out the I is equal to the square root of negative 1, and properties of radicals say that's the same as the square root of negative 1 times the square root of 40, and so I can just replace that as I. We've defined that, we've picked that, okay? Now I need to look at this and think, I've got I times the square root of 4 times the square root of 10, because 4 times 10 is 40. I picked those numbers because 4 is what we call a perfect square, which just means if you took the square root, it would be a nice whole number, not a long decimal. Or it'd be a nice rational number, I guess I should say. It'd be a nice rational number because sometimes a perfect square will be like a fraction, and that's okay. Okay, so this actually equals 2, so we'll have 2 times I times the square root of 10. Okay, that's little side work, little side math work for what's going on right there. So over here, this will become negative 1 plus or minus 2I root 10 all over 4. I already simplified over here. I need to simplify here. 2 times I times the square root of 10. Well, 2 over 4 is the same as 1/2. So what are the final answers? Well, the final answers are going to be negative 1 plus or minus, or plus, negative 1 plus I root 10 over 2, comma, negative 1 minus I root 10 over 2. There's different ways to write this. We could have left it all over 4, and if we had done that, it would simplify a little bit differently. This is how I want to write it, but don't worry, if you have an equivalent form, you'll get it correct, okay? That's it. We're done with question 1. Moving on. I'm going to pause real quick, actually. Okay, sorry about that. My computer was logging me out, and I wanted to log it in, so it stopped flashing. Question 2 on our Unit 4 Teacher Graded Assignment, Part 2. Consider the function f of x is equal to x cubed plus 2x squared minus 3. Graph the function. What are the x and the y intercepts of the graph? Okay, we have a cubic function here. So if you were not using technology, you would have to do something to see if you could figure out a root, if there's a rational root. The only possible options, that'd be kind of quick to check. We're not going to do that. I'm just going to go use technology. But you could plug in plus and minus 1 and plus and minus 3 into this equation, because that's the rational root theorem. So it's either positive or negative 3 or positive or negative 1, because remember, it's always the constant term, factors of the constant term in the numerator, and factors of the leading coefficient in the denominator. Well, the leading coefficient is just 1, so the denominator is just 1, so all whole numbers. Over here, the only factors of 3 is 1 and 3. So you have to do the positive and the negative option to see if it's a potential 0. If you do that, odds are it's not, only because I've graphed this before. So let's go use technology. Desmos, friends. You don't have to use Desmos if you have a preference. But if you don't, I have a preference of Desmos. One of the reasons is because it's embedded in the state test. That doesn't seem right. I messed up. Minus 3. X cubed plus 2x squared minus 3. There we go. Aha. So now, rational root theorem. If there's a nice rational root, it would be here. Oh, wait, 1 works. I was wrong. 1 works. 1 plus 2 times 1 is 3 minus 3. Oh, all right. Well, there you go. Okay, so we could figure out that that's going to be the x-intercept. I thought this was messy. I must have wrote it wrong when I checked it the other time. Mistakes happen. So I could have done some mental math there. There's the rational root theorem, so that's helpful. They don't always work, though. They don't always work. Let's see what happens if I change it. Yeah, see how that's not a nice number? That might be a repeating decimal, but they only gave us 2 decimal places. We can check this. X equals 0.82. Okay, so I just substituted that value in. This isn't our equation. Again, this is just me being curious. I hope you see, just explore the math. Why not? It's super easy when you have technology like this. It only takes a second. Ask those questions, think about it. If you don't have an answer, that's all right. That's the mystery of learning. There's a lot of unanswered questions out there. You're just getting the foundation to go answer them later on in your life. Or now, if you want to take the time to think about it. All right, so this one doesn't have a rational root. See how that doesn't equal exactly 0? So that's probably like a decimal that just keeps on going. So anyway, let me get rid of this. Let's go back to ours. The rational root theorem would work for this one, and you would find that the value of x equal 1 would make this equal to 0, which tells us that x minus 1 is a factor. So you could use synthetic division to figure out the other one. So we would have 1 as our divisor, 1, 2, minus 3, 1, 1, 3, 3, 0. Nice. Oh, Mrs. Reynolds. What did I mess up, you guys? X cubed, x squared, x? Nah, there's no x. Minus 3. There we go. That's more accurate. Here we go. 1, 1, 3, 3, 3, 3, 0. You can check my work. I multiplied, brought down. So now this is x squared, 3x plus 3. Okay, that's the cool part about this. Let's get rid of that. Watch, they'll match up perfectly. X squared plus 3x plus 3. The black graph perfectly on the blue graph. You could then check to see if this one factors, or you could use the quadratic formula, see if there's any other roots. I would argue this won't factor because, according to the fundamental theorem of algebra, there should be 3 zeros, 3 complex zeros. Well, there's 1 real 0, and no other parts are touching the x-axis. So there's 2 unreal zeros, or 2 zeros in the complex plane. So that means if we use the quadratic formula like we did in question 1, we would get a solution with the letter I. We don't need to do that. We just need to graph this So what could you do? We're done. We need to identify the x and the y intercepts. The y-intercept is 0, -3. Ooh, that's interesting. The x-intercept, I don't know if I just said that. The y-intercept is 0, -3. The x-intercept is 1, 0. Right? Notice that pattern. The x-intercept, x will have a value, the y will be a 0. The y-intercept, x will be 0, y will have a value. Then we need to kind of graph it. Here's like a peak. We probably need to zoom in. So how can we do this? Let's go look at our assignment really quick. It goes from 6, 6, and 6 to -6, -6 to 6. So I can go make my graph look like this, and we can try to graph it. So let's go there, up here. Click on the little wrench. I don't like the minor. We can make it thicker. You can even do reverse contrast. But if you like it and it's easier on the eyes. Oh, cool, -6. That's what it said. To +6. Great. Step of 1. The step are the tick marks. The scale, the distance between each part. And the step of 1. Okay. There we go. There we go. So there's our graph. We could try to go graph it. Okay, it looks like it goes like somewhere here. Ooh, between 3 and 2. Nice. Or you're welcome to do this. Click this. Click copy. Click here. Control V. You know what? When you turn it in, that's a live link. I can just click on it on your document. That's the way the course reads it. It's very cool, very exciting. I love it. Okay, that's one option. Another option, export image. Yep. Cool. Medium, thick, a medium square, large rectangle, a small square, oh, large square, medium square. Medium square looks good. Medium looks good. Download, right? Go to our paper, insert, pictures, this device, downloads, Desmos, insert. Boom. And then final option, or no, final tech option, snip, snip. You can even put your equation if you want. I have a funny face, but it's funny. Okay, and paste. My scrolling function doesn't work. However you like to do that digitally, you're welcome to. What did it ask us, though? It asked us more questions. What are the x and y intercepts of the graph? Well, you would do 1, 0, x-intercept, and 0, -3. If you were to do this completely by hand, you would make a table of values, and then you would plot the points. You get a couple points, and you would try to think of the curve. That's what you would do. Okay, so final option. Come with me. My scrolling function on my mouse doesn't work anymore. It's very frustrating. Final option would be to attempt to hand draw it. Some of you guys have done this. If you don't have the draw tool, you use like a curve, arc, a curve, the curve tool. And you might start like somewhere down here, you come up somewhere here, you come down here, you're clicking, you come through here, and then like straight up. Oh, there you go. And then you double click to stop. That again was insert, shapes, the curve tool. So right here, the curve tool. If you have draw, you could try to draw it, or you could do it from paper, or you could take a picture on paper and upload that picture. All right, we're done with question 2. Ooh, stay over there. Long division, show your work. It says long division, but I will of course accept synthetic division. What do they want us to do? If you want to use long division, that's fine. You're welcome to use long division. Let's use this sparkly one. And let's get going. Divided by. Well, that's going to be my divisor. I'm going to write it on the outside. I have to solve this in 6 minutes. Are you ready? This is my dividend. Is it okay? Is that sparkly one fine? That's x cubed. I don't know if that's easier to see or harder to see. It's just pretty. We're going to try it. X cubed minus 5x squared plus 7x minus 12. All right, we're going to switch. At this point for polynomial long division, it's a little bit different than synthetic division, okay? So what you're going to do is look at the first term for each polynomial. We're going to divide, so you do x cubed divided by x, well, that's x squared. You can also realize I want this when I multiply, divide, multiply, bring down, subtract, bring down, check, bring down, whatever. I want it to be exactly the same. So x squared times x is x cubed. Perfect. I want it to be identical. That's why we picked that answer. Now you have to multiply both parts, though. So we have x squared times -4. Well, that's going to be -4x squared. Great, but put parentheses because you're actually subtracting that. X cubed minus x cubed, distribute, that's 0. We want that to be 0. That's why we picked it. X or -4x squared minus -4x squared, that becomes a positive. So now we have -5x squared plus 4x squared. Well, now we're just left with -x squared. Remember, you just deal with the coefficients. -5 plus 4 is -1. It's invisible, so I don't write it. Bring the x squared with it. Check to make sure it makes sense, and then make sure your signs make sense, and then you do your bring down step. Okay? Repeat. Look at this. We need -x squared. Well, -x. -x times regular x is -x squared. We want it to be identical. But don't forget the 4. -4 times -x is positive 4x. Put those parentheses. Subtract. Negative or minus -x squared, that becomes a positive. We distribute. That becomes 0. That's what we want. We want them to cancel. We want them to undo each other. That's the whole point of this division. And then we distribute. So 7x plus 4x becomes 7x minus 4x. So 7 minus 4, minus, is 3x. You can check it. Check that you distributed. Check that the signs make sense. And then finally our bring down, -12. Almost done. Look again at the 3x, the x. Well, we want them to be identical, so multiply by 3. 3 times x is 3x. 3 times -4 is -12. Oh, that looks nice. Put parentheses around it, subtract it. It won't let me scroll. Need to scroll down. All right, here we go. 3x minus 3x, that's just 0. Distribute, that becomes plus 12. -12 plus 12 is just 0. So 0, that's exactly a factor. That's pretty cool. So what does that mean? Simplify the expression using long division. Show your work. What is the answer? The answer is just x squared minus x plus 3. That's it. For those of you who want to type it correctly, insert equation. It should automatically fix it once you hit the space. It'll type it like it'll type it with math notation. Okay. There we go. That's what it means when you're done and you simplify it. All right, thank you so much for watching. Please let me know if you guys have any questions. You could check your work with synthetic division. You could reach out to me. Let me, but yeah. All right, feedback. I always appreciate if you let me know this was good, this was bad, or what I could do better or differently. So again, thanks for watching.